Mind the gap. A warning you might be familiar if you've used the Tube of London. Where this might refer to a physical gap where you might trip and hurt yourself, we refer to a mental gap that you might experience when comparing AEM as a cloud service to classical AEM. My name is Dominik Süß and I work for Adobe Engineering in the guts of AEM as a cloud service with a focus on deployment and development specific topics.
And my name is Ruben Reusser, CTO and co-founder of Headwire, a passionate AEM and Sling engineering shop in California, who had the opportunity to partner up with Adobe and guide a few of the pilot customers towards a successful go-live on AEM as a service.
To talk about the gaps, we first have to clarify why things had to change in first place. And this was our challenge. We had to move into the cloud for an optimized resource usage and lowered entry barrier. This cloud solution had to also scale with the needs and avoid the need to overcommit resources for a rare peak situation. Having grown a pretty big solution over the years, we also had to modularize and separate concerns to be able to evolve and stay agile. But while changing how we do things, we were always aware that we would need to keep and embrace our ecosystem to make this transition a success. Last but not least, we had to consolidate the options to tame the operational permutations and focus on performance and resilience of one topology that fits and adjusts to the needs of all of our customers.
Based on the current state of things, Adobe has achieved some major milestones on that ongoing journey, I think. AEM has undoubtedly moved into the cloud with self-service provisioning, deployment, and automated scaling. Scaling and sizing discussions to prepare for the worst case scenarios are a thing of the past for us when deploying to the cloud. The structural changes in AEM and innovation presented over the last years, like ASIC compute or composite node store, can now be found in the cloud service, and in my mind, finally explain why Adobe started to draw a harder line around AEM's internals. Still, what we keep using are mostly the same APIs, the same base concepts, and AEM overall still kind of feels the same to me. The choices for topology might feel like a limiting factor, but in fact, it liberates you from taking operational aspects as additional vector that requires decisions, while Adobe now takes the responsibility to evolve this cloud topology to provide the functional and non-functional behavior our customers expect. You all may be familiar with the resource planning and complex install instructions, or if extremely lucky, scripts to handle deployments or maintenance operations in the past, right?
Now with the cloud service, we already provide you with a well-orchestrated self-served and automated cloud deployment where you only need to declare the source code and the desired state of the author and publish service via Git and let Cloud Manager and the cloud service automatically coordinate the rest. For a rough orientation, here a quick reminder of the general unified topology that AEM as a cloud service is built on. The core is the container orchestration service with fully isolated namespaces per environment that elastically scales the containers of publish and author service based on performance and utilization metrics, as well as coordinating the execution of environment-specific maintenance jobs. These containers are wired with a bunch of shared multi-tenant services that handle storage of content and binaries, distribute the content between the containers, roll out new application versions, scale the caching of content delivery, or process the assets efficiently without affecting the AEM performance. Further services for add-ons or enhanced features such as Adobe Sensei integration may also be wired in or will be wired in the future. But this should give you a rough overview over where we are standing as of today.
So now the question for me is, how does this affect us when implementing AEM for our customers? We have been working with AEM as a cloud service for a while now, and it's still the same AEM. Well, not the same. The legacy stuff we tell customers not to use anymore has been removed. In my book, that's a win. But more importantly, Adobe is still with us. As an Adobe partner, I feel welcomed into the new cloud service. There are differences, of course. Before, we had to figure out the best way to deploy AEM for our customer and their IT infrastructure. Now, a lot of those choices have been made, and we can be sure they perform. Or if they don't, it's a problem that can be raised with Adobe directly, and then Mr. Süß has to fix it for us. It's kind of nice. If this wouldn't be virtual conference, I'd be asking the question right now, who hasn't been in the position to come into an AEM project after somebody else already implemented AEM and then first has to figure out how AEM was deployed? How did they do X, Y, and Z? AEM as a cloud service is not much different in that respect. It's a base that we all have to understand to add our projects on top of it. At least now that base is consistent from customer to customer.
But let's go through some differences affecting development flow, deployment, and runtime behavior to highlight the gaps you might not notice at first sight, where you would want you to be aware and dig down a bit deeper on your own and reach out to the community where details might be missing. First of all, due to the complexity and specifics of the orchestration of the cloud service internals, it is not feasible to ship a cloud service in a box that you can run on your machines and evaluate everything. Therefore, the SDK contains a runtime that from an OGI standpoint can reflect the runtime of an author or publish environment, but in contrast to the cloud service is mutable when it comes to bundle states, configuration, and application content. The consequence of these differences is that you do have differences that make the local SDK suitable for fast ongoing development iterations that you want to for functional testing and validate that you don't break functionality and implementation as it is going on and that your implementation is doing what it's supposed to do. The dev environment, regardless, is if it's a sandbox or a regular environment, is the first level where you have full cloud integration and can perform an integrated functional validation. For this environment, we also work towards better introspection options than we can provide on stage or prod due to the security considerations. For the non-functional testing, you can already start on the dev environments running on the same infrastructure, but to evaluate the behavior and the stress, you might need to switch to stage as this runs under the same scaling conditions as production does. Stage is also the environment you should use for end-use acceptance testing and hook into the Cloud Manager pipeline that provides you the hooks to activate those checks and include the functional test execution.
Even though local deployment can be used for most dev tasks, you might still experience differences on the cloud environment, especially the non-functional changes and the differences in configuration might cause trouble where introspection into the application can become necessary. The system console that we still have available in the local SDK is being replaced with the dev console, which isolates the often required introspection features of the system console in a central place with access to all the active containers. And when it comes to logging, the way logs are made available limits you to writing to the error log. All you should consider there in the future is registering additional loggers to increase the log level for debugging purposes, consume the logs through the AEO CLI Cloud Manager plugin, and use simple basic tools like grep to filter the stream for the messages you are looking for.
Product rollouts shouldn't affect you too much in stage and prod, despite of the windows in which the pipeline might be blocked for a running product rollout. These rollouts happen continuously up to a daily cadence and is based on a release pipeline that evaluates each candidate against a wider set of cloned custom environments and further evaluation techniques. As dev environments cannot be considered stable and may even be hibernated in sandbox environments, the rollout of updates is currently being self-serving and requires you to trigger it. Just as it is up to you to take care that your local SDK is being kept close to production. This is some additional toil that we are already actively discussing and are evaluating ways on how to simplify these updates on your end.
A significant change in the deployment towards the cloud service against what you experience in the local SDK is the fact that OSGI state, as well as the application content, so apps and libs, get baked and are immutable. The reason for this is that scaling up the service will expand the author service by rolling out new cluster members, or the publish service by expanding the publish farm by additional publishers. Both tiers share that the startup is supposed to happen as fast as possible, so a reusable and immutable state of the application is being built ahead and the mutable content in the current state just mounted in. In consequence, changes to the immutable part can only happen with the deployment, and any programmatic change of the OSGI state at runtime would need to be baked by mutable content. In other words, there is no deployment or configuration editor, as the instances may be recycled and reset their state at any time. On the other hand, mutable content cannot be changed with deployment, as the switch from old to new version happens in an instant, while the new version of the application will join the topology behind the scene ahead of time. Mutable content is always live, and therefore changes to mutable content happen at runtime. For the content packages that you might want to deploy with the application, this means that the job will execute after the switchover to the new application already happened, as there might be content changes in your packages that are incompatible with the old application version that would cause trouble before the switchover.
To clarify the rough flow, we captured a simplified sequence of the blue-green deployment of the author service. While Blue in version 1 is currently serving the mutable content, a decoupled process prepares version 2 of the immutable data. As this is decoupled, any mutable changes coming with the deployment, for example through mixed packages or repo init statements, would be dropped from this preparation. At the moment, this involves a startup of AEM, but this will go away eventually, so you should not build on any logic relying on a startup of the AEM instance. When the green immutable state is ready, the actual deployment is getting invoked, and one or more containers are being started up, parameterized with the corresponding environment variables to bind the matching configurations. Repo init is also executed and must only contain change sets that won't break blue, as this is actively serving traffic until green reports readiness. As soon as green reports readiness, a switchover signal is sent to the load balancers and a termination signal being sent to the blue containers. Those will shut down with a grace period of multiple minutes to ensure the completion of potential long-running responses. As new traffic will be routed to the new green containers, this is the time when the job for mutable content installation will be invoked, and when it would be safe to execute logic that introduces content Blue is not aware of. The most obvious scenario for this is the introduction of changes to editable templates or other changes in conf that relate to an updated application state that cannot be baked into apps.
So, when implementing, we need to be aware of a few implications of this. There is always one version serving the traffic at a time, but two versions may be running concurrently in the topology, making everything not being invoked by user requests potentially subject to incompatibilities. In consequence, content must stay compatible with the blue version until the switch to the new version happens. The Sling topology sees the mixed version state, and the topology events are propagated across both versions until the blue versions leave the topology based on the termination. A deployment rollback only affects the application state, and for the automation, this means that if the deploy fails, blue will keep serving and any change green applied before switchover will stay in the system.
A pretty special case is the update of index definitions, as application may be depending upon an index being ready to serve to perform correctly. Therefore, indexes are applied before the switchover and even before the green instance are started, because depending on the index definition, this may be a long-running process. This can stretch the pipeline execution duration, but guarantees a clean zero downtime switchover without risking to have a full tree traversal or similar, like picking the wrong index that would mess with the productive experience. We can't go into the details, but the query engine can essentially handle multiple versions of an index definition in parallel, where the blue instance would bind to one and the green instances would bind to the other version of an index. The binding is handled behind the scenes and can be steered by proper naming of the indexes. For further details, please consult the documentation. Let me also go back to mutable content packages a bit, just to reiterate your options. Remember, content packages containing immutable content are applied after the switchover. Also, we have the constraint that you cannot separate installables by the environment type, so dev, stage, and prod will also all receive the same content. The reason for this is the destructive nature that content packages can have, and that the mutable content job is running basically unsupervised, which means that no one observes the output in real time, noticing that the package wiped out crucial content. By having the installation happening at least on stage already, we have some confidence that you could properly validate the package not doing any harm in an automated installation. And as packages can be so destructive and can introduce a big binary footprint, we would rather suggest to consider repo init for changes that are compatible with the blue version, or have changes applied later at runtime after the switchover via some targeted scripting, for example, using Sling pipes as a project solution.
A major difference for the operations side is that procedures are no longer based on environment-specific runbooks and installation guides with the manual validation steps. So we do have the challenge how to expose health information out of our application into the system to understand cases where the application is no longer healthy beyond the platform health that Adobe monitors. Adobe currently uses Sling health checks and the Felix service ready checks, but is currently in the process of swapping those out by the Felix health checks that merge those two types of health checks. As soon as those are available, those will provide us a way to hook in a new readiness and liveliness checks that expose application-specific health information. But before you hook those in, you should understand the implications of those two types of checks. Readiness defines when the system has been fully initialized and the system is ready to serve content. A failing readiness check will cause a deployment to fail. That means if a service is not starting up or a backend that you check its responsiveness has been misconfigured on the environment, it cannot be reached. This will protect you against getting an application deployed with a misconfigured environment. Liveness, on the other hand, defines if the running system is currently healthy. The important thing to know is that the system that's unhealthy for a certain time will first be taken out of load balancing and eventually recycled. Therefore, this should not be abused for backends responding with error codes or similar, as a restart won't resolve the issue. In this case, you rather should implement circuit breakers and make your application resilient against breaking backends.
As we are moving towards an elastically scaling system, it is crucial to us to keep the footprint of the individual runtimes low to guarantee a fast ramp-up and shutdown of instances. For fast recycling and an immutable application state, the file system is ephemeral and limited in size, and it won't survive the recycling of instances. Binary processing in general is expensive on almost all ends. I/O, CPU, and memory would compete with the synchronous request processing tasks that reflect the real-time user experience. As solution to this challenge, we introduced direct binary access to prevent the AEM instance to be busy with passing binary streams back and forth. Asset processing has been externalized and used direct binary access behind the scenes to read and write the binaries without consuming resources of the AEM instance. An open challenge we will eventually tackle is the externalization of content packaging. Although the implementation supports binary-less packages, the handling of snapshots still involves building huge snapshot packages, embedding the binaries, and also the consumption of the exports would require the download of the reference binaries from the blob store to be of any use. For now, you should just be aware of those limitations of handling those binaries within the runtime and avoid cases where you pass or even process binaries in the runtime, and keep the size of the binaries you need, like content packages, under control.
Another challenge a lot of us experience is the proper handling of asynchronous logic in a cluster scenario. In the past, isolating the execution to the leader was in most cases sufficient, and restart scenarios were either controlled or outages, making cases where we might lose events an edge case. In the cloud world, instances may come and go and will be replaced by new instances, making leader re-election a thing we have to keep in mind, as well as the timing of shutdowns, in which oak events or scheduler invocations may not yet be handled or completed by a specific instance while it is already shutting down. Kaushal Mal and Yurko independently wrote some nice blog posts we can highly recommend to reconsider your coding practices for asynchronous or scheduled tasks in such a dynamic topology.
Last but not least, we want to cover the topic of replication, which was significantly redesigned for the purpose of elastic scaling. Instead of the individual replication agents per publisher, we now have a single replication stream handled by the Adobe Replication Service, which keeps a record of all the replication events over the course of 1 week and can be replayed from any point in the queue. This allows new published instances to base on stable revisions and just replay from the replication queue until they caught up, and provide a reliable fatal recovery scenario where the state of an instance can be restored to any point in time within this week. The implications of that is that the extension hooks for replication are in big parts deprecated and would mess with this centralized content distribution support. Additionally to that, the consumer on the publisher had to be switched from an administrative session to a service user. This, in consequence, can easily lead to blocked pipelines and even lead to failed Cloud Manager pipeline executions when you try to deploy mutable content on the publishers where the service user has no permissions to apply it. And just a short note on the impact of replication architecture on deployments. Because we do have replication as a single content entry, node replication is halted while rolling to the new golden publisher until the task caught up. The switchover happens after this process has completed. There still is an open challenge which refers to the fact that replication may be blocked by invalid items, which can affect the ability to perform a deployment. To solve this, we would want to be able to identify invalid replication items and reject them before they can enter the replication queue.
And with that, here are our personal takeaways.
Continuous deployments and a streamlined operational setup finally allow us to rapidly evaluate and roll out optimizations of AEM. We can validate against real customers without causing disruptions while being closer to the customer implementations. Instead of waiting up to a year for my code getting used, I now get feedback within days, and we can iteratively work towards the best solution.
It is nice to see AEM evolve at a faster pace. Finally, our work is shifting away from customizing older versions of the AEM monolith towards adding true value to AEM customers and the ecosystem by leveraging the cloud, microservices, Adobe I/O, NUI workers, and Firefly against an always up-to-date AEM versions. It's really time to start embracing the cloud and think a little bit outside of the monolith that AEM was, and think more about how can we solve issues for our customers in the cloud. All right, I think we're open for questions. Dominik, do you want to take the first one?
Okay, so yeah, I hope I queued that for live answer already. Yeah, so the question we already received is, how is the developer supposed to perform local development and deployment on his local machine for local developer testing without having a shared dev environment? So essentially, there is not that much of a difference as you have for on-premise. Basically, the SDK as you can download it today is composed of the quick start. So right now, it basically is development as in the past. As indicated, this is not an integrated environment, but typically integrated testing is in most cases not about functional testing, but about non-functional testing. So we consider that you can do most development work there, at least code changes, and only for cases where you have to test integration, you deploy into the cloud service. I hope that answers the question.
There's a new.
Yeah, so there's another one about like how can we test clustered scenarios? A job is running interrupted and then started. Yeah, that's a quite detailed question, or quite deep question. In general, you can set up yeah, well, integration, like yes, integration testing you can do in environments. Locally, you could set up, you have a quick start. You can set up a local cluster. You can have a setup with Mongo. Like the configuration of that is a bit more challenging to set it up to provoke cluster scenarios. For most things about clusters, it is about following the guidance and the practices. As long as you follow them, you won't have trouble. It's the same kind of challenge that you have with concurrency, like testing multi-threading concurrency issues is a hard thing to do, or provoking that locally.
So as I would like to add, and since we're already out of time, it is actually quite interesting to use the cloud-ready quick start also with Mongo, because it can show you issues that you might have in the cloud in an authoring instance. So it's a good thing to do that, in my opinion, at one point, because then you can test multiple authors and you can also test other things that happen. But I think we're over time, so
yeah. So I'm just taking the last one, like how to debug production issues, and this is about how the logs will be exposed. Basically, if you go through the AIO client, you get a stream, like all the error logs are aggregated into one stream that you're getting. But you can also access the streams from the individual instances. And yes, the new instance, the green instances before switchover, will already pop up and be you'll be able to select them and also to download the logs after the fact, if in case they have trouble during the deployment.
And then there's one more. We can answer that one as well, right? The question is about
So if figuring out how like if the pipeline is broken, this is basically the pipeline exposes you the information that it is blocked. Like, so if you go into the dashboard, into the distribution dashboard, you see the pipeline noting that it is in a blocked state. And if your pipeline timed out before, it's like you can just look into the corresponding deployment logs, and you will probably see that there is an issue with the corresponding instance. There are a few edge cases where you currently don't see it in the logs, which we try to optimize, but essentially the blocked flag is a strong indicator.
All right, thank you very much. I think that's it from our side, right?
That's from our side. Thanks, folks. See you. Bye.
Thank you.